So you're growing up a rancher, going into the military, get this opportunity at the steel mill. You get to work with your dad, which is awesome, even though he was probably a little afraid that you're in that type of environment. The reliability engineering, how does that end up applying to the oil industry? How do you go from reliability engineering at the steel mill to end up working with big oil at Texaco?
So at that time, reliability engineering wasn't actually a degree you could get. You were a mechanical engineer, and reliability was considered a part of that, like a sub part.
Yeah.
And how the person brought it to me was, your job is to find things that break and go to the root cause. What caused it to break? So that way it doesn't break on the next one. Or what can you implement so that we don't have these things break as much in the future? So for me, it was just like going back to puzzles and a challenge. I'm like, okay, how did this break?
Yeah.
Let's make sure, what caused the break, and was it a part, or was it a person? Is it practices, or is it physical parts that this part isn't good enough, and so forth? And I found that such a great stimulation for me, because then it was like, okay, now I need to learn more. So now it's like, okay, I need to learn about these parts. I need to learn about manufacturing. I need to take classes. And I did. I went and took a calculus-based statistics class. Why? Because that tells me of all the parts that are made, how many are going to break without you doing anything? The part by itself, 3% of these parts when we make them are bad parts. And I was like, well, that adds a lot to the equation.
Yeah.
Because I'm thinking every part made must be good. And like, oh no, when we manufacture these parts, we've done the numbers, 3% we make are terrible. They don't work. And I'm like, oh, well, 3% is that. Well, how many are not as good as 100%, So
Yeah.
I really always pushed myself to learn more and more and more. So the lubricant side of it came in primarily from the money. The people willing to pay the money was the ones that are like, okay, our equipment's not working. What's the first cause? A lot of people, you've been in the business long enough. What's the number one cause? People say, oh, it must have been the oil. It must have been the lubricants.
Yeah.
It couldn't possibly be our operator, It had to be the lubricants, And in the steel industry too, it was funny when I'd come up to stuff. I'd come up and I'd look at a bearing and I'd say, whoa, that bearing got pretty hot. It's blued. So blue in coloring means it got 600 degrees.
Yeah.
It's pretty hot. Then I'd look at the grease. Grease looks pretty fresh. I'm like, man, we better bottle this grease. It must be the best grease Texaco ever made, because it got 600 degrees. It didn't even discolor.
Yeah.
Like, this is fantastic grease. And I'd look at the guy. Did anybody add grease to this? Oh, no, we would never do that. I'm like, oh, okay. But that was where you play that little cat and mouse game. I'm like, you wouldn't blame the lubricant, but I'm pretty sure there was no grease in that when that bearing got hot, So we'd play that cat and mouse game. But it really inspired me that the lubricants company is the lifeblood of most equipment. If you're going to be in reliability, lubricants is the first part of it.
Yeah.
There's not a machine out there that doesn't have lubricants in it. So then you spend all your time going, okay, well, what's new in lubricants? Why are we using a formula that's 50 years old? Are you telling me that they haven't came up with something since then? So that was always that challenge. And I always pushed people in all the companies I've worked for. It's like, okay, what's the better mousetrap? Why be a me too? Why make a product just like the one they made 30 years ago at another major oil company?
Yeah.
Because just because they invented it 50 years ago don't mean it's the best. It will always be the best from now on. There's got to be a better way to make a better product. And that better product means the equipment lasts longer. And that's been my drive, I guess, for now 30 years, because I've worked for a lot of, and it's why I've left the Texacos. The Texacos are like big government. They're tough to move.
Yeah.
You could have the greatest ideas and say, hey, I want to make a product that might work in this application. And they're like, here, fill out these forms. In 3 or 4 years, we'll do a test. 5 or 6 years, we might market it. If we can sell 1 million gallons of it, we'll sell it. So I've been drawn a lot more to family-owned, smaller oil companies. And nowadays, they call them specialty lubricants companies, because that's how they make their money. It's like, what is it that the majors aren't making that we can make and make a lot of and make good money at? So I've been drawn to those kind of companies.
Little anecdote to that point. Last night we had the family over, and I had shown my daughters just a little clip from Ford versus Ferrari, where the Ford, beats the Italians, and they're like, "Yay, America!" So they're like, "I really want to watch that movie," and I'm like, "Yeah." We don't normally watch like adult movies with our young daughters, but it's a pretty wholesome movie, and I like it because it's like a capture of time in America. And there's a scene, right, where Shelby comes in and he's about to get canned by Ford. And it's like he basically has to tell a story that's going to save his job, right? And he tells that story and he talks about it and he focuses on a lot what you just said. And like after it's done, he kind of inspires, Henry Ford II, and he walks out and he shows him the assembly line and he's like, 3 out of 5 bombers came off that assembly line during the war. He's like, this isn't the first time we went to war with the Europeans. He's like, go to war, Shelby. And it was just awesome. Like to see that.
What I like about that movie, because I have watched the movie, it's a good movie, is that he could have told the guy through a lot of reports and stuff about the car. He's like, yeah, I could have gave you stacks of reports how great this car is. He's like, let's go for a ride. Puts him in the car, and that guy's screaming the entire time. He's like,
they're weeping at the end of it.
And he's like, that's where your money went, right there.
Yeah.
He didn't need to show him all these books and all these reports. He's like, this is what it takes to win at this. And he's pretty much like, yeah, let's build this car.
Yeah. And you need the right driver behind the wheel to handle that machine.
It's how I've done some of that kind of stuff in my career here, where we take new technology. I don't want to name drop too much, but when I started looking at ways to improve some like reliability in open gears, they came up with this thermal technology, which we were using in electrical. And I am an electrical engineer by degree. So I'm like, oh, this is kind of neat technology. I bet I could use it for open gears, and some of these other checks that I do. And the company I work for is like, I don't know. It's a lot.
Yeah.
That's expensive. I said, well, buy me one camera. We'll see if it pays out, So they bought me an entry level camera. I showed them just like the Ferrari. I showed them all these things that their eye couldn't see, but they kind of thought they'd been in business. I'm like, yeah, I think this is something that
a suspicion that they can't prove,
but I could prove it. And pretty soon they're like, okay, well, if you're going to prove it, you need to put it in magazines so other people see that you're proving it. And then some of our competition had to start following what we did. They never talked about it until we did it. And then suddenly now it's in their literature like, oh yeah, me too. We do this thermal imaging also. So it took off. So I was like, okay, that's great. And it's really morphed into stuff. Now you see it everywhere. Infrared imaging on bearings and gears and everything. It's gone everywhere. And we was the first ones to really kind of publish a lot of that. So it's like a feather. So then when like these 3D printers came out, plastic printers, I said, hey, there's a use for this. There's a place that we can use this. And they're like, oh, we're not going to do it. So I had the wife buy me one as my Christmas gift. Because, I'm sure just like you, anything that you really want in the world, either you save for it or you've bought.
Yeah.
So Christmas is always a tough around our house. Like, oh, what do you need? There's nothing I need.
Yeah.
But I was like, hey, my company probably could use this technology, but
they just don't realize it yet.
Yeah, they don't realize it. So she bought me a 3D printer. And when I started printing some of these models and stuff of customers' equipment, the sales just went through the roof because customers like, you looked at my equipment and you drew this up on AutoCAD and printed it out, and now it's sitting on my desk and I can take it apart and we're not out there risking our lives in this noisy environment. Like, yeah. He's like, how many of these can you make? Like I was an assembly line. I was like, I can make you one.
Yeah.
We can lease to new customers.
Yeah. I don't have a shop of elves doing this for me. Yeah.
But it really morphed. And now I'm seeing that technology take off. I saw some just the other day where this guy had this beautiful, I think it was a gyratory crusher. All the parts look like the actual parts, because they got multiple filament printers and stuff. Right. What a great way to teach the younger generation. And I did a magazine article again on that technology is being absorbed now by the Navy, not the way that we would typically think, but they're actually using it to make parts. If you think about, you want to buy a part for a Navy ship, it has to be made somewhere and then has to sit on the ship because the ship doesn't come back in. And nowadays they're using this same technology so they can make brass gears and other metal gears on the ship.
Yeah.
So they just have to have the map. And I'm like, well, in the big scheme of things, it's what we would need if we ever want to go to space. Say we want to populate on the moon and make a mining, camp on the moon. You have to make those parts there. They can't ship them. You don't have time to ship them. So,
yeah.
I think of it from like a Napa standpoint. You can imagine there's going to be a day, hopefully in my lifetime, you can go into Napa and they say, oh, what year is your car? It's a 24 Ford. Okay. What part do you need? Okay. And he just goes there and hits print and prints the part up. So you're not stocking 6,000 parts. They just print it up for you and hand it to you. it's coming. The technology's already there, and that's where that timing comes in.
Yeah.
I'm hoping to be there for that because I think it's going to be very interesting to go through that aspect of life. I know that we were like in that fundamental stage, and they were just thinking, what can we do with this kind of technology?